Hey guys. Saturday, 1:30. Hope you guys are enjoying yourselves. I'm here taking one for the team, but I'll be out of here soon. I wanted to take a moment to recap something that we did when I last saw you. Okay, the whole idea behind the linear regression test for the slope, when our beta, which is our population slope, is equal to 0, is to establish that there is no relationship. So we're saying no to the HO, no to the HO. Okay, just like we have before. And with that understanding, if we're going to fail to reject the HO, which means support it, that means if there's no linear relationship, what is the point of using that as a prediction line? Which takes me to this point. There's no value for that prediction because it was a line that we rejected that we should have used in the first place, because there's no relationship between the line that we made and any prediction. And I want you to jump down to number 14, and familiarize yourself with that, please. Okay, so yesterday we were talking about, here we found the equation of the line, making sure we have our, defined our variables. We talked about, again, what the value of S is. That value of S here is the standard deviation for the residual, also known as a standard deviation or standard error of the regression line. We also talked about how our y-intercepts are not always plausible, because in this case we're talking about you had the kids that had no time at the table, but they still consumed 560 calories. And how does that happen? Again, if they could only eat when they were seated, how are they consuming any calories? But now I want to talk about part C, which we didn't get to in most classes. We are about to do a linear regression T test. We are trying to see right here if there is any type of evidence of a linear relationship. So our HO is saying that there's no linear relationship. And remember, beta is representing our slope, but the HO is saying there's no linear relationship. And here we're basically saying there is a linear relationship. They were nice enough to give us our conditions and assumptions that have already been met. They're nice enough to give us our test statistic. Yes, we know it's two-sided because it said not equal to, and our p-value. Let's remind ourselves of where those two values are. On our table, here is your test statistic, so no calculations necessary, and here is our p-value. So now we know, based on that, and they gave us an alpha level that they required, which is 0.01. That means we can conclude, since the p-value is less than the alpha level, and here are the values right here, we're going to reject the HO. So yes, we have convincing evidence of a linear relationship between the time at the table and the caloric consumption of the toddlers in this population. Now I want to turn to problem 16 on the next page. And I just need to make sure that you have this data in your calculator, in your L1 and in your L2. And then we're going to be jumping into this hypothesis test, doing this the long way, so we can see where different figures come up. And given that this might be a partial problem 6 on the AP test, yeah, we need to talk about it. But we'll talk about this more tomorrow. Make sure this is in your calculator. Speaking of problems that are difficult, problem number 6, I'm on page 10 of our notes, and we are talking about two methods of comparing the wear estimated wear on tires. So please read that scenario. Now you see we have a computer printout, and we already talked about this on Friday, coming up with our verification of our confidence interval. So we just took the confidence interval, plugged the values in there. We did it by hand. Remember, here is your slope, your test statistic, your t-star, We had to find that in our table, or inverse t for those of you who have the 84s. For those of you who have the 84s, remember what you have to put in is your alpha level, which is right here, 0.01. Divide that by 2, and your degree of freedom, which they said there were 16 of them, so that's going to be 14, because remember your degree of freedom is n minus 2. But for the rest of us, we had to use our table to get to the 2.977. Here it is, and when we crank it, we see that we're going to get, we can verify that that's the value. But we didn't have a chance to finish the other parts. So now this is a question 6 waiting to happen. So the researchers are testing, but they want to test this hypothesis right here. They want to test that it equals to 1, and the alternative that it does not equal to 1. And the reason for this is because what they're really looking for is they're looking for measurement of wear here. So they're trying to see, in this particular case, if as one increases the unit, is it reasonable that the other is going to increase by 1 unit. So basically we're talking about, we have a slope here of 1/1. Now, the beauty of this is that in Stats 1, which is what we're in, we will be given our HO and HA on a problem number 6 they give it to us. We don't have to figure out what it is. As opposed to the other one that we just had to do, we had to determine that our beta was going to be equal to 0. And that's the only thing that we're going to have to figure out again in Stats 1 and for the AP test. However, for Part 6, they're going to give us this, and then they're going to ask us a couple questions. They're going to say, as we look at Part C, compute the test statistic. Now, here, I know you're thinking, oh, just like the other one. Here, we have the test statistic. No. That's the test statistic that's used only if there is a difference. So, here, we can't use that because we cannot use this because, like I was saying, this is only utilized when there is no linear relationship. So that's the only time they did the calculation for the test statistic for us, which means, if that's not right, we can't use that either. Okay, and if you want to test it, go ahead, do the math. You're going to find that when beta is equal to 0, which is not what we're testing now, but when beta is equal to 0, you're going to get that value. But bah humbug, we have to do the math ourselves. So let's remind ourselves of the formula. The formula is the baby B minus the Greek B divided by the standard error of the slope. So here's the naked formula, and here's the formula with the plugins. At least they gave us the slope, and they gave us the standard error of the slope. But we have to do the math by hand. 84s, you might be able to do it in the calculator. I don't know. Hopefully you can. Here, after you found your test statistic, then we're going to have to use a table to find our p-value. And remember here, it is, where is it? It's two-tailed, so we've got to double it. And we find out our p-value is going to be between 0.1 and 0.2. Well, that's really kind of close, because didn't we have an alpha level somewhere of 0.01? Yes, we did, because our confidence interval was 99%. So as you can see what I have right here, Because our confidence interval was 99%, that makes our alpha level 0.01. We have a p-value that's greater, barely greater, but nevertheless greater than 0.01. So we're going to fail to reject or support the HO. So we do not have convincing evidence that the slope of the line that relates to the wear of the measurements of the tire using the different methods that they differ from one. So we don't have the evidence to support that information.